Hello friends, welcome back to your UPSC. So today we'll start with another topic of geomorphology, that is isostasy. So let's get started. So what exactly is isostasy? Isostasy means a mechanism of stability or mechanical stability between the low-lying and upstanding part on the rotating earth. So what it means that, see, our earth has many features like mountains, plateaus, plains, hills, and they all are quite nicely balanced on earth, okay, while the earth is rotating. So how and what is the thing or the force that is making them stand so stably? Okay, so how are they standing so without any disturbance? How are they so stable? So that is what we study in the concept of isostasy. So now we will study about how this concept actually came into existence. So in 1735, what happened? During the expedition of Andes, Perrier, he actually found a discrepancy. What was exactly the discrepancy? It was that the volcanic peak of Chimborazo was not able to attract a plumb line. Okay? This volcanic peak was not able to attract a plumb line, which it should have done, as the Andes is having so much mass. Okay, Andes is having so much mass as they considered that the whole crust is having a uniform density, and that is about 2.75 gram per centimeter cube. Okay, and now with this density and this large mass having this much volume, the attraction force would be much higher and it should be able to attract a plumb line. Okay, but it was not able to attract, so what Perrier concluded, he concluded that the attraction of Andes is much smaller than that was expected from the mass represented by a mountain. Okay, and this similar type of discrepancy was experienced during a geodetic survey of Indo-Gangetic Plain. What exactly is geodetic survey? Geodetic survey is a survey in which the latitudes are determined. Okay, here latitudes are also determined. So during latitudinal determination of Indo-Gangetic Plain, Sir George Everest, who was Sir George Everest? George Everest was Chief Surveyor General of India. Okay. So what actually he actually saw that there was a discrepancy, or there was a difference of about 5 seconds between the latitudes of Kalyanpur and Kalyana. Okay. So these are the two places near Himalayas. So what Sir George Everest was trying to do, he was trying to determine the latitudes of these two places by two methods, that is triangulation method and astronomical method. See, these two methods we are using to determine latitudes, so latitudes must come same, but there was a difference of about 5 seconds. He again used another instrument because he thought that there might be some fault in these instrument from which he is surveying, but there was again a difference of 5 seconds, and exactly we can say 5.236 seconds. Okay, so he actually thought that this difference or this discrepancy was attributed due to the attraction of Himalayas, because the Himalayas were attracting what they were attracting. See, triangulation method is a mathematical method, so in this the Himalayas cannot attract anything, but in astronomical method we use the whole survey tools, and in which plumb bobs and all other metallic tools are also used. Now in the astronomical method there must be some attraction, and because of which there must be some discrepancy or some difference in calculation. So this whole difference was due to attraction of Himalayas. And To further evaluate and describe and clarify this thing, the matter was sent to Pratt. Okay. Now, when this matter was sent to Pratt, he actually calculated, he actually mathematically calculated this discrepancy. Okay. So he took the density as the average density of mountains as 2.75. And now with this density he calculated the the discrepancy. With this density he calculated the discrepancy mathematically, and to his surprise what he found that the discrepancy which was originally coming, it was 3 times less than the calculated discrepancy. The calculated discrepancy was 15.885. Okay, so this was much more than the actual discrepancy. Now, after this matter, there were many questions that arose, that why there is such low attraction force of Himalayas. And for this, there were various explanations given. So the ones were, firstly, the Himalayas must be hollow. Okay, so one concept was that the Himalayas must be hollow and inside would be consisting of bubbles. Inside would be composed of bubbles. So this concept was outrightly rejected, because this thing can't happen, because such a large mass can't stand without having anything inside, because the earth is rotating and due to gravitational force of earth it would have collapsed, but there is no such case. Second is, the density of rock of mountains must be relatively low down to considerable depth. Now, all the mountains must be having the low density. See, as we go down, there must be considerably low density. The third explanation was that the rocks of Himalayas must only be consisting of low density. Okay, the rocks of Himalayas must only be of low density. That can also be the case. And the fourth one was that if there is a big column, that is, if there is a big feature on earth, that is, if there is a mountain, it must be having low density, and if there is a smaller feature like plateau, it must be having higher density than mountain, but this plateau will be having lower density than a plain. Okay, so these were the four explanations, and on the basis of these four explanations our further concepts were formed. So now let's study about the concepts of isostasy. So the first concept was given by Sir George Airy. In this concept, he said that there is a Sialic layer and Sima layer, and according to him, Sial is floating on Sima, and for this he gave the example of boat. See, a boat is floating on water, and this boat is having uniform density all over. So what he said, that the part which we can see outside, much more part is sink inside. Okay, so there is much more part that is sinked inside the water. Likewise, in the same is the case with the earth. Just a second. So same is the case with the earth. According to him, if this is the feature, any relief feature, if this thing we can see outside, the 9 times the length of this Okay, the 9 times more is inside. Okay, if we have 1 kilometer above, 1 kilometer above the sea level, so below in the substratum, it would be 9 kilometers. Okay, so with this concept, he actually he actually did an experiment. He took a tumbler in which he filled mercury, and then say the same can be done with uh, water and wooden blocks of uniform density. What he did was with mercury, with iron rods. So he took iron rods of different length and he placed it in in mercury. Okay. So all these iron rods were arranged in this pattern. So he observed that the part which was outside, the part which was seen outside, the 9 times that part, okay, the 9 times that part was inside. And with this, he concluded that the same thing was happening with our Earth. That is, if there is a feature above the surface of Earth, in the substratum, its root would be 9 times its length above the Earth. Okay, but what happened was, its drawback was that, or its criticism was that, the root, if 9 times, what he was saying, if the roots were 9 times of the length which was above the surface of Earth, then in the cases of Himalayas, the root would be equivalent to 79,632 kilometers. Okay, which is not practically possible because from here we have liquid. Okay, like at this much length we have liquid, or the area is in molten state and the root cannot exist any further. Okay, so this concept failed to explain this. The next, so this was the concept of uniform density given by Airy. Next was the concept given by Pratt. He actually rejected the concept of Airy and he said that the such a long route cannot exist. So he gave the concept of line of compensation. Okay. So in it, what happened was he took mercury in which he placed blocks of different metals having different density. Okay, like he put lead, then iron, aluminium, antimony, zinc, etc. etc. Okay, so these were of different density. And what happened was all these uh, metals were arranged at same level, okay, at same line which he called as the line of compensation, beneath some depth. Okay, inside some depth they were arranged at the same line. So what he concluded was that we have different features on Earth, that is mountain, plateaus and plains, etc. etc. So the column which is having the lower height, okay, or the smaller column will be having higher density than the bigger column. So the mountains are having lower density than the plateaus, and plateaus are having lower density than the plains. So the plain must be having the highest density and the mountains must be having the lowest density. Okay, so that was his concept. He believed in line of compensation. Okay, that is law of compensation. And varying density. While what Airy did, Airy believed in law of flotation and uniform density. Next, we come to the concept of Hayford and Bowie. They actually believed in not in line of compensation, but in plane of compensation. Plane of compensation means that the area which is, I mean, the column which is having the rock of lesser density. Okay, there is a rock of lesser density. It would be standing higher than the column which is having the rock of higher density. Okay, so see, if it is having the density of 2, it would be having the density of 3, and it would be having the density of 4, and they all are at the level of compensation or the plane of compensation, which according to Hayford and Bowie is below or is at the depth of 100 kilometers. Okay. So simply we can say that their concept was that the varying volume of matter, that is the matter having different volume, okay, in several column is compensated by their density. Okay, if they are having more volume, then they will have less density. Okay, in such a fashion that they exert equal downward pressure. Now the volume and density will give equal amount of pressure. Okay, so if we are having more volume, then we will be having less density, and the pressure would be exerted will that would be exerted would be equal. Okay, so that was the concept given by Hayford and Bowie. That is, the more the volume, the lesser the density, and the lesser the volume, the more the density, so that they can exert equal pressure. Next, we come to the concept of Joly. He actually did not believe in any line or level of compensation. He believed in zone of compensation. Okay. So what he said that there is a zone of uniform density. Okay. So there is a zone of uniform density below which there are like about 10-mile thick there is below this there is a 10-mile thick zone of compensation. This is zone of compensation. So this zone of compensation is about 10 mile thick, that is about 16 kilometers. Okay, so this concept is actually a close agreement with the flotation idea. Okay, what was the flotation idea? That was the idea of Airy. Okay, this concept is close agreement with the flotation idea, and the area of low density, the area of low density in the 10-mile layer will be exerting a downward projection of light continental crust. Okay, so The area of low density in the 10-mile layer correspond with the downward projection of light continental crust, while the higher density represent the intervening areas filled with the material of heavier understratum. Okay, so like if this is a area having lighter density, it would be exerting lighter pressure, and if this is the area of heavier density, it would be exerting heavier pressure in this zone of compensation. Now next is the concept of Ohms. So in this concept we can simply like say that just a second, I'm out of focus. So Holmes actually followed the concept of Airy, and he assumed that the upstanding crystal part was made up of lighter material, and in order to balance them, the major portion of the higher column was submerged in a greater depth, okay, of the lighter material. See, if there is a major portion here, so it would be in a greater depth. So it was, this concept was same as Airy. And according to Holmes, the higher column of are standing because of the fact that there is a lighter material below them. Okay, so the higher thing is here, it is standing because there is lighter material inside them. Okay, below them. That is, they are having low density. Now, if we like diagrammatically understand his concept, then it is like this. This is a plateau region. This is mountain, plain, coastal plains. Okay, this is sea floor. They all are having the density of like they are having the density of 2.7. So the roots of this part will be much deeper. Okay, this is the Cialic layer. Below this we have Sema, whose density is 3 and its density is 2.7. So he illustrated the concept of equal weight along with the level of equal pressure. So they are exerting equal pressure. Okay. And because they are exerting equal pressure, this will be deeper and their impact will be much lesser. Okay. Now we come to the recent view. So what actually our recent view says that it says that it is not a isostasy is not exactly a local phenomenon that is happening like this is the mountain, here it is stabilized. So it is not like this. Exactly what is happening is it is a global phenomena, like there is mountain which is rising. Okay, because of its rise it is denuding. If the erosion process is accelerated, okay, and because the eroded particles are then transported and they are deposited, okay, they are deposited here, and because they are deposited they subduct, okay, and when they are subsided they reach to the lower level, and when they reach the lower level uh, they liquefy because of the heat of the earth, and as they are liquefied due to tectonic movement they reach to the other places. Okay, And as they are reaching to the other places, this is the substratum, okay, and they are flowing. And when they uprise, okay, when due to compressional pressure or anything like that, you can understand all the tectonic movements, they uprise. And due to their uprise, this mountain is further elevated. Okay, so this is a cycle, not a local phenomena. That is our recent view. Okay, so our recent view says that it is not a local phenomenon, but it is a global phenomena which is occurring. And because of this global phenomena, our these things are stable on the earth. Okay, so that was all in isostasy. So with this we come to the end of our lecture. I hope you enjoyed the class. So we will meet in our next class. Till then, take care and have a nice day.